There's never enough time unless you're serving it. That's true. Work consists of whatever a body is obliged to do. Play consists of whatever a body is not obliged to do. Sure, but like, is there something there that's not obvious? I don't know. I think it's just like a statement of fact. Oop, music's too loud. A little loud. Okay, teensy bit quieter, and then that's good. Okay. Yeah, it's a good song. So yeah, I think most of the stream today is going to be reading some more papers about cancer modeling, unless someone distracts me with a question, of course. Because tomorrow we need to. There's gonna be like an in-class like session where we kind of talk about what we want to do for the project, and I want to have a better idea of what I want to do. In this paper, I see the word games, and so I immediately just kind of want to not do this paper, but let's at least skim it and see what they're talking about. I don't really want to do any game theory stuff, though. So the abstract heterogeneity and strategies for survival and proliferation among cells that constitute a tumor is a driving force behind the evolution of resistance to cancer therapy. The rules mapping the tumor strategy distribution to the fitness of individual strategies can be represented as an evolutionary game. Sure. We develop a game assay to whatever that is to measure effective evolutionary games in co-cultures of non-small cell lung cancer cells. God, what a non-small cell lung cancer cells that are sensitive and resistant to anaplastic lymphoma kinase inhibitor alectinib. And they're only quantitatively different between different environments with targeted therapy and cancer-associated fibroblasts. Qualitatively switch the type of game being played by the in vitro population from leader to deadlock. I guess this is game theory stuff. This observation provides empirical confirmation of a central theoretical postulate of evolutionary game theory in oncology. We can treat not only the player, but also the game. Okay, I'm losing even more interest in this. Although we can concentrate on measuring games played by cancer cells, the measurement methodology we develop can be used to advance the study of games in other microscopic systems by providing quantitative description of non-cell autonomous effects. Can you chat know what Moore's circle is? I never heard of that. Thanks for the streak, Rex. Also, thanks for the streak earlier, Thunder. I guess I do, Slim. I just don't know much about game theory to start with, and trying to like the point of this project is to take an existing academic paper and like evolve it in some small way. And I think game theory, like game theory is a somewhat common thing to use for cancer modeling apparently, but I just don't know the first thing about game theory, and so that seems like a bad idea to take on something involving game theory. There was a word in here that I wanted to Google though. I can't. What was that word? I already forgot it. I don't remember what I wanted to Google. Oh wait, I not in here. I wanted to Google Moore's circle. Hey Skirt. Dude, I want to build that frigate so bad. If I can get enough homework done today, I might hit you up again. More circles, a two-dimensional graphical representation. You know, that'd be great, Skirl. If you could like read these papers for me and suggest a project, that'd be great. Well, there's a lot more papers than just these three. What will your fortune? You will step on the night soil of many countries. Doesn't night soil mean poop? Don't worry about it, it's fine. Oh, about Morse circle? Okay. I still want to see just what it is. 3,000 articles in 8 hours? How is that humanly possible? I think you're an AI. Two-dimensional graph representation of the transformation law for the Cauchy stress tensor. You're built... Apparently you are. Oh, this looks annoying. You're building AI? You're built different and you're building AI. That's crazy. It's a lot easier than it looks. Okay. This is a few too many sigmas for my taste. Like this picture here has 9 sigmas. Jake, you say your AI? I mean, maybe. Rex, the project it's really open-ended. It's just choose pretty much any academic paper about cancer modeling and either synthesize a few related ones as like an easier kind of alternative. But the thing that I want to do is like take the work that a paper is done and just extend it in some way. It doesn't have to be very big, but just like add in some new element that the paper didn't do. And so there's a list of suggested papers that would be good to work from, and so I'm working through that list of like suggested papers. Okay, so this one is almost certainly no. Let's at least scroll through it and see if we see an interesting figure or equation or something, though. Who cares? Oh, whoa, what's happening? Okay, there's at least a lot going on here. This looks like they made it in Python. How do you... Dude, getting Matplotlib to do this would be crazy. I feel like whoever made this graphic was just showing off. Parental growth rate, resistant growth rate. I don't really understand what any of this is saying. I don't care enough to put the effort in to figure it out. Huh. Rubik's Cube? We can do that. I know the differential equations. I mean, I guess it makes sense differential equations could be related. I wonder how often they come up in game theory, though. It wouldn't be that hard. I already got a pretty decently big thing done today before the stream. It's not really done, but oops. My really annoying homework assignment for my hard class. I now have at least some sort of answer for all the homework questions. I still need to go and like clean it up though. Just scrambling it right now. Okay, good enough for me. Inspection time. Okay. Oh fuck! I'm choking. Wait. Oh no! I'm choking in so many ways. Oh fuck! My Okay, there. Terrible solve. I almost did mess up. I have to like start over from a previous step. I discovered a clever way to match DNA profiles without revealing the sequences. They encrypt the sequences first in vector form, then do a dot product. Oh, yeah, that is clever. That's a great way. That's actually I really love that example as a way that you can use like or like when you first learn linear algebra, you kind of fall they teach you in a very geometric way that can become a hindrance in a lot of applications of linear algebra. And that's a really cool example of like a less geometric but still important application of linear algebra. It went okay, Slim. I I I I I I feel I feel like I have the same problem this year as I did when I gave a as when I gave a talk last year on Shane Stream, where it despite my best efforts to make things simpler, I think it was still too complicated, and I should. I think that less might be more if I did it for a third year. Like, and instead of trying to prepare something elaborate, I should be a little more casual about it. I still think that I showed some like cool things during that stream that I am happy with, but I don't know. If you want to learn enough linear algebra to understand finite element analysis, finite elements. Well, actually, wait. Is finite? Let me, because I'm thinking of the finite element method, and I think that's the same thing as finite element analysis. Hey, Aeneas. Yeah. Okay, so I have tried to learn the derivation for even the most basic version of the finite element method before, and it's kind of difficult. But you might not be asking to derive it, you might be asking just to use it. Good, because it doesn't teach you linear algebra. Um, I'm trying to remember what type of like how, I don't remember you needing that much linear algebra. Like I mostly remember just being able, like, you should be able like to convert like sums into equivalent matrix equations. Inf. Supermum to you two. I from my recollection, you don't need that much linear algebra. Like, you just need to understand that a matrix equation is the same thing as a system of equations, and you need to be able to convert kind of from one to the other in some kind of difficult looking cases. But I don't think you need very much. I don't think you need null space. You're traumatized. Yeah, I mean, if I were you, I would just try to start learning finite element method and learn the linear algebra you need as you go. I don't think you're going to need anything super deep. No worries. Yeah, it's pretty cool. I don't think, as far as I've heard, Python doesn't have uh an existing library to do finite element method for you, but MATLAB does, and it's a professor of mine like kind of did a demonstration with it, and it's pretty cool. So if you have MATLAB access, that could be worth like messing around with. The virus I was spreading, making you play Russian roulette. Be kind of a funny virus. Okay, let's see what this paper's about. Inferring mutation history of a tumor using multi-state perfect phylogeny mixtures. So your passwords as well. Yeah, password schmassword. Studying mutations in cancer genomes using multiple states enables improved analysis of phylogenetic relationships. Between populations of cells in a tumor. If I Google perfect phylogeny mixture, what comes up? Computational phylogenetics, which phylogenetics, I think that's how genetics like present physically. Phylogenetic tree. Uh, the loaf. Oh my god, that took me a minute to figure out what you were saying, Fluffy. The loaf Jenny. Yep, that's exactly what we were saying. Thunder or Tunda was asking how much linear algebra you should need to know to learn about the finite element method, and I think you only need basic linear algebra for that. Like the finite element method to numerically solve PDEs. A phylogenetic tree. Let's see what that is. Yeah, it's like pretty much the most general numerical algorithm for PDEs, as far as I know. And by general, usually the issue is like it works on very weird domains. Pretty much any domain you want to throw at it. Hey, Manel, welcome in. If I'm saying that right. Graphic representation that shows the evolutionary history between a set of species or taxa. Yes? Okay, I'm glad I got it right. One or more populations of an organism. Okay. Who cares about that? Does a branching diagram or a tree showing evolutionary relationships from various biological species of their entities based upon... Okay. All life on Earth is theory part of a single phylogenetic tree, including indicating common ancestry. Phylogenetics study phylogenetic trees. The main challenge is to find a phylogenetic tree representing optimal evolutionary ancestry between a set of species. Now, what does this mean? Like, what is the optimal evolutionary ancestry? Happy you're finally done with linear algebra for a moment. You think you maxed out on calculus that doesn't require linear algebra. Taking vector calc soon. Wait. So you're happy you're done with linear algebra, but you're excited to take vector calculus that does involve linear algebra? What do you mean? No worries, Manel. It's good to have you here. If you master determinant, you'll have a really good time with vector calc. When do you use the determinant? Like, I guess for Hessian matrices? I don't remember where else you would use it. Oh, true. Jacobians. That's fair. Yeah, and Manel, if you have anything that you want to talk about or ask about, please do let me know. You like calculus, but for further calc, you need to know about linear algebra. Oh, okay, okay. So you're happy that you've like, okay, yeah, I understand now. It's like you've unlocked the next phase of calculus. Yeah, I mean, vector calculus is where things get really actually useful for learning deep like physics and stuff. Because like single variable calculus is great, but it's kind of like limited. Vector calc coming up with a good parameterization / change of coordinates half the battle. Yeah, true, true. But physics, integral go burr. It's still even not for physics, still really useful for like complex analysis, PDEs. Can't wait for measure theory. I I mean, it is incredibly useful, and I want to learn some measure theory too someday. I think actually learning it would make me probably not like it very much though. I still want to learn it even knowing that, but the first measure theory course in my uni is kind of blah. I imagine it's pretty difficult to make measure theory exciting. Took a cross-listed measure theory course. Like, was it open to multiple departments or something? I don't know what cross-listed means. Oh, nice, nice, Manel. So yeah, for background, I'm working on a master's degree in applied math, and on my streams, I will work on homework unless someone asks me a question. And so the thing I'm doing right now is I'm reading through some papers about cancer modeling, basically. So it's like mathematical biology stuff. So I'm gonna need to do a project on some paper at some point. So I'm trying to come up with ideas for that project. There's a lot of just like chatting like this though too. Studying statistics, so you get the faster you get measure theory, the better. Oh yeah, those are very like related things. You were in 4th year undergrad. Oh, that's what cross-listed means. Okay, yeah. And actually, Dentistry. Oh, cool. Good luck. Math and physics are your favorite, but you're studying dentistry. That's kind of interesting. Um, yeah, so whenever I do see new people around, I do like to let them know I'm not the only math streamer out there. There's a little niche of us here on Twitch. Um, and so you don't need to go and follow like every last person in that list, but like there's a bunch more streamers out there than just me. So if you're new to this niche on Twitch, I encourage you to like take a look around and see who streams you like. I'm trying to think of like someone who streams frequently and speaks French in math, but I only know people who stream like occasionally. Unfortunately, it's like measure theory before discovering the third edition of Kallenberg's book. Really, it was just you select measure theory, but you're also traumatized by it. Okay, that's fair. Took more to defeat you than it did me. Crushed by Fallen. Taking topology 1B, starting that vector calc. When I'm done, going straight for the measure theory. Nice. Have you done real analysis? Or I imagine like your calculus classes there are a lot closer to real analysis. So maybe it's probably just different there compared to America. Topology is awesome. I know basically nothing about it. The first measure theory course is pretty much a course in real analysis. Really? Hmm. Call real analysis even though it involved a bunch of complex numbers. Representation theory. Apparently, I know nothing about measure theory. Then I thought it'd be about like Lebesgue integrals and stuff like that. That was called real analysis. Wasn't quite as rigorous as I've seen real analysis elsewhere. Okay. So yeah, I know in general like European like universities or even just like but before universities tend to emphasize proofs in like pure math a lot more than American schools. Their course in measure theory is usually a course in C star algebras or ergodic theory. Okay. So they called it calc. Fair. Analysis with real numbers and finish. Okay. Makes sense. Okay, you know, I'm getting paranoid because last time I streamed, I don't think anyone typed in the YouTube chat, and I want to make sure that I'm not fucking something up. Oh wait, no, I think Papadori maybe typed in the last one. Okay, good. I do have the right window open. Okay, that's fine if no one's typing. I just want to make sure I wasn't like I've had it before where the stream was accidentally set to private and I didn't realize for like 2 streams. So much to study, so much time. That's not how the saying usually goes. Okay, so I'm still trying to figure out what the hell perfect phylogeny is. All internal nodes in this phylogenetic tree may be labeled so all characters down the tree without homoplasy. This is okay. I'll click through on another link, Wikipedia. Describe a feature that has been gained or lost independently in separate lineages over the course of evolution. And we're doing this without homoplasy. Gained or lost independently. So without any repetition, characteristics do not hold to evolutionary convergence. Ugh. Okay, it's saying that separate species don't happen to evolve in the same way. Do not have analogous structures. Okay. Presented as answers having state 0 and all characteristics where 0 presents a lack of that characteristic. Choose characteristics change from 0 to 1 exactly once and never reverse a state 0. Okay, that's... I guess this is the math person's explanation. That's what I needed to hear. What kind of math do you learn in American high schools? So when I was in high school, we were required to take Algebra 1, which is like, I think it's just like single variable equations solved for x and like the equations of lines and stuff like that. Basic geometry, so like triangles, squares, angles. And then Algebra 2, which is like parabolas and conic sections. As far as I remember. And then if you want, you can go further and do trigonometry and pre-calculus. Which is like more about polynomials, and you kind of learn a little bit about like limits. And then a lot of schools also offer actual like university level calculus classes too. And you can also do statistics, usually as like an optional choice too. Eyes are evolved separately, each eye individually. I don't think they mean that. I think they mean like once some organism evolved eyes, everything else that has eyes came from that organism, I think is what this is saying. Are you going to make a video for the summer math expedition? They do both start with AC. Nah, Slim. I don't know what I would make a video about. The thing that Stuki put together with like the review-a-thon was pretty fun though. I would do that again. Are you planning to? I remember you had a mix-up last year where like you accidentally submitted a different video, but it still did pretty well, I think. In France, you study algebra, functions, trigonometry, probability, and the final year derivatives and some integrals. Advanced math option go into more theory like matrices and number theory. Really? So yeah, that's interesting to hear that you guys go further. And I guess for us, high schools between the ages of like 14 and 18. So I don't think it's like a universal thing. Yeah, no, we definitely do not have like linear algebra or number theory in high school. That's cool that you guys do. So you think you're mildly dyslexic? Different species. Sorry if I misinterpreted you, Rex. All right. I assumed you're just like making a joke. You'll make one, not sure what you'll make it about though. Okay. You have a topic you love to make a video about. You don't know how to make videos. Probably just be me narrating in PowerPoint. I mean, that'd be something. Just because it's like a 3 Bill and Brown competition, I mean, it has to be in that style. And yeah, if you do make one, please feel free to like share it in my chat or Discord too. Okay, so so these people are using perfect phylogeny to infer the mutational history of a tumor. Bulk tumor sequencing measures somatic mutations. What is a somatic mutation? God, I should probably not Google every last word that I don't know. I'm going to be here for a while. A somatic mutation is a change in the DNA sequence of a somatic cell. Yeah, okay. Multicellular organism with dedicated reproductive cells. Any mutation that occurs in a cell other than a germ cell or gametos. What is a germ cell? Oh, okay. It makes gametes. Or germ? I think I said the G wrong. Maybe is it germ or germ? It doesn't matter. It's fine. Okay, but it's anything that's not in those cells. Okay. I don't know how you pronounce that, germ or germ, Floppy. Oh god. Like Germany. Okay. Thank you. That's what I needed. I was thinking of germ like a germ that makes you sick. Like germinate. Okay. That's probably it. That's a good like word to relate it to, I bet. Especially algorithms required to infer phylogenetic trees from mixtures. The spruce algorithm constructs phylogenetic trees jointly from SNVs and CNAs. Many phylogenies are consistent with multi-sample bulk sequencing data. Okay, summary. Phylogenetic techniques are increasingly applied to infer the somatic mutational history of a tumor from DNA sequencing data. However, standard phylogenetic tree reconstruction techniques do not account for the fact that bulk sequencing data measures mutations in a population of cells. Right, I remember that about zygotes. Bulk sequencing data measures mutations in a population of cells. I don't know what this means. Maybe we'll figure it out as we read. We formulate and solve the multi-state perfect phylogeny mixture deconvolution problem of reconstructing a phylogenetic tree given mixtures of its leaves under the multi-state perfect phylogeny or infinite alleles model. Unlimited alleles. Oh, Skirtle. From the YouTube side, okay. Well, usually people do type there. They're being degens, so good luck. Unlimited alleles. Do it. Degen sound experience. True. I'm too busy being Dr. Palpatine. I already forgot what I just read. We formulate and solve the multi-state perfect phylogeny mixture deconvolution problem of reconstructing a phylogenetic tree given mixtures of its leaves and the multi-state perfect phylogeny or infinite alleles model. What it means period dramas. Yeah, that exactly, Scriddle. This is a perfect cover. You know, it's probably funnier not to explain it too. I might if it lags like hell when I'm watching something interesting. Oh, I'm sorry, Rex. Your #1 top fan? Haha. My biggest fan. I'm screenshotting that. Our somatic phylogeny reconstruction using combinatorial enumeration. Spruce. Ugh. Algorithm uses this model to construct phylogenetic trees jointly from single nucleotide variants and copy number aberrations. I'm kind of souring on this paper. This it feels like I need to learn a lot of background stuff to figure this out. We show that Spruce addresses complexities in simultaneous analysis of SNVs and CNAs. In particular, there are often many possible phylogenetic trees consistent with the data, but the ambiguity decreases considerably with an increasing number of samples. These findings have implications for tumor sequencing strategies. Suggest caution in drawing. This is such a weird way to suggest caution in wait, these findings... Oh, these findings suggest caution in drawing strong conclusions based on a single tree reconstruction and explain difficulties faced by applying existing phylogenetic techniques to tumor sequencing data. Okay, let's see if we can look at some figures. Here's some figures. Ooh, if we're making vectors, that could be kind of cool though. Characters, taxa. Read my lips. No new taxas. Let's see if we can figure out what this is saying. Okay, let's read the caption first. In the multi-state perfect phylogeny problem, we're given a matrix A whose rows are the state vectors of the taxa. We seek to find a tree T that satisfies the infinite alleles assumption and whose leaves correspond to the taxa. Okay. So characters. I don't know what... I don't know what's what here. Hey, Femvox. Hope you're doing well. Actually, are you back to tutoring, or is your university or college already on break? Actually, well, no, you guys still tutor in summers, right? I know, Femvox has a Femvox emote. I am confused. So is each column a different tumor? Like these are two different samples? I think each row is a sample, actually. Rows are the state vectors of the taxa. Okay, yeah, so each row is a tumor, and a tumor is a taxa. And these tumors could have... They have two characteristics that could have a 0, 1, or a 2 state. Okay. And so given these like end results, we're given basically the bottom row of this tree, and we have to figure out what the top part of the tree is. You're watching Zach the other day and the lights cut out? Oh no. My semester ends next Tuesday, but yeah, we tutor summers too. Okay, okay. The eternal streak of 3 continues. You should be able to have a streak of 3 streaks. Okay, so I understand graphic A. What's up with graphic B? Perfect phylogenetic mixture deconvolution problem, PPMDP. We do not observe the taxa directly. Oh. Set our measurements F correspond to the mixtures of the leaves of a tree T according to unknown proportions U. Oh god. The goal is to infer T and U from the frequencies F of each character and state in the sample. Measurements F correspond to mixtures of the leaves. Okay, now I'm lost. I guess we know the proportions. I'm kind of confused by what these... Why is that C, 1 in this leaf? And star, 0? Okay. Lee and Lee. Oh yeah, true. Huh. This one is probably gonna be a pass. Let's scroll through a little more though. This could be kind of a cool paper. I just don't want to unpack what all this means. So hey, Dessen. This is kind of a cool, just like aesthetically, this is kind of a cool graph here. Baths. Okay. I think that one's going to be a no for me, dog. Oh, wait, let's scroll through a little more. I feel like Georgia O'Keeffe made this graphic. Okay, yeah, no. Next paper. Okay, resistance to chemotherapy. Patient variability in cellular heterogeneity. I am indeed a ball knower. I first learned about it because I went to someone's house and they had like a Georgia O'Keeffe painting. Elite art ball knowledge. I mean, I don't know. I assume it wasn't an original. I assume it was just like a reproduction of it. And so, uh, yeah. And so like, the person who owned the house like pointed it out. I noticed it on my own, but I didn't say anything until a person said it. Why am I smiling? Do you not know who Georgia O'Keeffe is, Dessen? And then, but yeah, it was cemented because they talked about her in Breaking Bad. Jesse and Jane. Remember, it wasn't like it was just like a little like throwaway thing. What's cellular heterogeneity? Uh, it's cells that have some sort of differences, I guess. Like heterogeneity refers to differences between a group of things. You were watching when it got to the part of their marriage falling apart, selected it and got genuinely uncomfortable for me to watch. Oh, like Waltz and Skylar's, yeah. Sounds too upper hemisphere to me. What word would you prefer to use? Okay, well, let's see. The issue of resistance to targeted drug therapy is of pressing concern as it constitutes a major barrier to progress in managing cancer. One important aspect is the role of stochasticity in determining the nature of the patient response. We examined two particular experiments. The first measured the maximal response of melanoma to targeted therapy before the resistance caused the tumor to progress. We analyzed the data in the context of a Delbruck-Luria type scheme. Ooh, this sounds familiar. Oh, Georgia O'Keeffe? Uh, she's an artist, and all her paintings look like vaginas. That's the joke I was making. Wherein the continued growth of pre-existent resistant cells are responsible for progression. Hey, Sage. I've been streaming some, just I haven't had time to stream as much. Hope you're doing well. Delbruck-Luria type scheme, wherein the continued growth of pre-existent resistant cells are responsible for progression. Yeah, I'm doing well. Thanks for asking. Okay, we show that aside from a finite fraction of resistant cell-free patients, the maximal response in such a scenario be quite uniform. To achieve the measured variability, one is necessarily led to assume a wide variation from patient to patient of the sensitive cell's response to the therapy. The second experiment is an in vitro system of multiple melanoma cells. Oh, myeloma cells. Oh, myeloma. When subject to a spatial gradient of chemotherapeutic agent, the cells in the middle of the system acquire resistance on a rapid 2-week timescale. This finding points to the potential important role of cell-to-cell differences due to differing local environments, in addition to patient-patient differences encountered in the first part. I think it's an easy way to be a well-accomplished research. Math Oncology must be a rich area of research, I imagine. Is there any easy way to be an accomplished researcher? I bet this is relatively easier. Like, if you want to, like, I bet there's a lot that you can do in this niche, because like you could always find some specific enough situation that someone hasn't looked at and do something with that, I bet. So I bet there's like still a lot you can do. So because there's just so many different varieties of cancer that have their own attributes that you could account for mathematically. Okay, let's read a little bit of the introduction, because this one could be a good one. One of the most important challenges facing the oncology community is moving toward a better understanding of the emergence of drug-resistant treated cancers. In a typical scenario, a targeted molecular therapy such as a BRAF inhibitor or an anti-EGFR antibody is given to a patient. The patient experiences a transient reduction in tumor burden, measured by an MRI. This reduction can be quite extensive. Yet all too often after a few months, the tumor begins to grow back, and soon the therapy fails as fluorescence emerges. Right. Seen or read a social science research paper? No, I don't think so. Like firmly social science and not anything to do with math? No. Like no more math than your average research paper would have, at least. Like the furniture paper will use like, or a lot of papers will use like a value or something of some kind, or statistics. But like besides that, let's start scrolling a bit. See what this figure is. Survival time months, survival probability. Alimta is some sort of treatment, I assume, versus a placebo. Ooh. That's unfortunate. This p-value is right around 5%, I think. Or like the confidence intervals just... Oh, wait. Yeah, they just barely overlap. Went to a conference months ago. Professor from Northwestern spent 1 hour talking about a poem. That doesn't sound very social sciencey to me. Calculated Stanford prison experiment coached the students. I feel like I've heard of that. I don't remember what that is, though. Wait. $15 in 1971 is the same as $119 today? Well, last year? Inflation is wild. Um, It's kind of crazy. People just pretending to be prisoners. Or guards. Yeah, this seems messed up. Oh, so I guess this is the coaching part that Meme Machine Rex just talked about. Okay, yeah. That is messed up. Most beautiful campus I've been to? I don't know if I've been to that many college campuses. I'm trying to think of any well, okay. Like Hawaii, where I went to for my undergrad, the campus itself wasn't particularly beautiful. I mean, it had a beautiful part, but like Hawaii in general is beautiful, but the campus wasn't like anything special, I don't think. The local state school where I'm from, which is fine. And then the only other place I can think to I've been is my current school, UW, and that's freaking beautiful. I really love campus here. I went to Hawaii. I must be. I had a decent scholarship, and living in Hawaii is cheaper than living in the part of California where I'm from. Hey, Halo. Okay. I'm doing good. How about you? Oh, it is expensive. It's just more expensive where I'm from. I did not, and I regret it. Actually, are there observatories on Oahu? That's the island that I was on. Uh, Lilo and Stitch movie scenes? I never even thought about that. Oh, wow, there are observatories. This is a terrible website, by the way. They're they've chosen dark blue on dark blue. This is a random website, goastronomy.com, observatories in Hawaii. So Kaneohe, like I lived in Kaneohe in my freshman year. So I could have gone there and I didn't. Pearl City, it's kind of out of the way. It's like I think it's like an hour away from Honolulu where I lived in my second 2 year or in my last 2 years. To get from one end of Oahu to the other, it's like 2 hours. I don't know what I just said about Pearl City. I think it's like 1 hour. Maybe it's a little less. I don't remember. Is the native language hard? I had hardly ever heard anyone speaking the native language. Um, I'm sure it would be hard, but I don't really know. Never seen me with a pineapple shirt? I do have two Hawaiian shirts. I have to see. I don't think either of them have pineapples though. I was tempted to break out a Hawaiian shirt last week. I didn't actually do it, but I got this one. I think both these I got from Ross even. Then I got this one. So yellow flowers, not too off from pineapple, but yeah. Like Zuko from Avatar? Didn't he wear like a robe or something? Let me see. Is that like Zuko? I like both those shirts a lot. Well, this one. This is the art website. Oh god. Oh, that text is disgusting. How do you have such a terrible website? Yeah, no, I agree, Jed. Okay, Lindsay Mancini, Chris Mandelbaum. I'm sorry to call you out, but wait, edit this page? Oh, okay. Page history. Okay, fine. You think the Math wearing Hawaiian shirts are nicer? You know, I could actually get behind that. It's like a MySpace blog. Yeah. What? Okay. The images are all broken. You know, that is big and ugly, though. I gotta hand it to this website. Regretsy? We gotta see what's up with this. I do not have a Prussian website, no. Regretsy sounds hilarious. Non-ugly website with hideously ugly stuff sold on Etsy. Is this website not up anymore? It's taking forever to load. Be sad. I think it's down. You want to click on anything? That's fair. Oh well. Ooh. Okay. So this resistant to chemotherapy, patient variability and cellular heterogeneity. I guess let's just scan for equations and figures here. Number of mutant cells plus 1 for some reason. Because it's a log scale, I guess. That's a really weird fix, but okay. Occurrences per 100 cases. Theoretical 100 random cases. Luria-Delbruck distribution number of mutant resistant cells. So there's a lot of occurrences of only a few mutant cells, is what this is saying. What website language supports LaTeX or even TIX? I don't know. I bet Zach would be able to answer that question. Am I ready to get pumped? Volume warning? I'm a little scared it's gonna play a noise. I'm clicking on it. Oh, okay. The official Ninja webpage. Ninjas are mammals. Ninjas fight all the time. The purpose of the ninja is to flip out and kill people. Oh my god. Look at the no link. Okay. Oprah.com? Okay. Order book. The official ninja book. Oh, this is a real book on Amazon. Basically, you shouldn't buy the real ultimate power than official ninja book. You're a moron. You're an idiot. That's a hell of a website, Jed. Good find. Feeling you just gone to the deep side of the internet? It's a good guess, or a good feeling. Recent experience with ChatGPT 5.5 Pro. Okay, I'm not gonna read all. Oh, fuck! This is a long one. Oh, okay, no, it's not. This isn't the entire thing, but it's a little long for me to read the entire thing. But let's get the gist at least. We are all having to keep revising upwards our assessments of the mathematical capabilities of large language models. I have just made a fairly large revision as a result of ChatGPT 5.5 Pro, to which I am fortunate to have been given access, producing a piece of PhD level research in an hour or so with no serious mathematical input from me. Does this have a date? No. Okay. True, Jed. The background is that, as has been widely reported, LLMs are now capable of solving research-level problems and have managed to solve several of the ERDOS problems listed on that website. Initially, it was possible to laugh this off. Many of the solutions exist in the LLM. Noticing the problem had an answer sitting there in the literature already. Could be very easily deduced from known results. I mean, that's still helpful. But little by little, the laughter has become quieter. The message I'm getting from what other mathematicians more involved in this enterprise have been saying is that LLMs have got to the point where if a problem has an easy argument, for one reason or another, human math should have missed, then there's a good chance that the LLMs will spot it. Conversely, for problems where one's initial reaction is being pressed and LLMs come up with a clever argument, it often turns out on closer inspection that there are precedents for those arguments. So it is still just about possible to comfort oneself that LLMs merely putting together existing knowledge rather than having truly original ideas. I feel like it's pretty rare for humans to have original ideas. We definitely do, but it's rarer than I think this sentence implies. How much of a comfort that is, I want to discuss here. Yeah, okay. I decided to try something a little different, at least in combinatorics. There are quite a lot of papers that investigate some relatively new combinatorial parameter that leads naturally to several questions. So the sheer numbers of questions one can ask. The authors of such papers don't necessarily have time to spend to think about each one, so there's a decent probability that at least some of them will not be all that hard. This makes such papers very valuable as source of problems for mathematicians who are doing research for the first time. They'll be hugely encouraged by solving a problem that was officially open, or rather, it used to make them valuable in that way. So the bar has just been raised. Yeah, Leo, Destin just linked this and asked me for my opinion on it. I don't want to read the entire thing, but I want to get the gist of it. In any case, a little over a week ago, I decided to see how ChatGPT 5.5 Pro for a selection of problems by Mel Nathanson, a paper titled Diversity, Equity, Inclusion for Problems in Additive Number Theory. Okay. It says a record of being interested in problems and theorems that have later become extremely fashionable. Just let him try to series extremely well timed and therefore highly influential textbooks. Paper argues the interest of several other problems, some of which I will now briefly describe. Destin, you're being paged by Leo. I'm gonna skip over the problem statements. Destin, to the front office, please. You're in big trouble. Another natural question one can ask, and this is where ChatGPT came in, is how large a diameter you need. Sure. 17 minutes, 5 seconds for writing construction that yielded a quadratic upper bound, which is clearly best possible. Wrote up its argument in a slightly rambling LLM-ish style, so I asked if it could write the argument up as a LaTeX file in the style of a mathematical preprint. YouTube automated that one. When using the law of sines, find the length of a side. My calculation should be in radians instead of degrees. It depends what you're given in the question. If you're given degrees in the question, do degrees. If you're given radians, do radians. Oh wait. First, wait. I need to look at the law of sines again because we gotta be given an angle, right? So if you already have one of the angles and it's in degrees, then your calculator should be in degrees. You have two angles and one length. I don't think so. Or it depends, like, I think it's just, like, what are the two angles? I think you just need to make it match whatever you're given. Right. Yeah, I don't think you would just always use radians. It just depends. Yeah, that sounds like degrees. So I would do degrees there, otherwise you'll get the wrong answer. Yeah, it's like you could convert those into radians and then use the radian setting, but you should just use degrees and make your life easier. YouTube channel with only TI-84 tutorials, you have a lot of views. I bet there's already a lot of those out there, Destin. That's usually the problem with math YouTube. Um, yeah, so if it involves pi, it's probably in radians. If it doesn't involve pi, it's probably degrees. Like 30 degrees and pi over 6 are the exact same thing. It's probably a little bit too small to read, but it doesn't matter. Like 30 degrees and pi over 6 are the same thing, but it sounds like you have degrees and you should use the degree setting. Like technically you could call those radians too, but that'd be a super weird number to have in radians. No worries. I saw the sign from the ace of base of the triangle. Is there actually a spoof song like that? Hope your dinner involves pie. Sounds nice. I'm going to YouTube. Oh, okay. You're just making a joke. If that song doesn't exist, then someone should make it. I saw the sign. I am a super weird number to have in radians. Have you ever tried calculating the sign of dawn? It's not easy. All right. I'm still skimming through this blog post. Is it going to do something unexpectedly good or bad? Is what I'm trying to figure out. You ever tried reading my draft textbook chapter? I have not. If there's somewhere I can find it, I can give it a look. For 16 minutes and 41 seconds, came back with an argument that claimed to have improved the upper bound from exponential and k to the alpha for any alpha greater than a half. Find it, it needs you. Is it posted online somewhere? Oh, no. Like, if you post a link, I don't even have access to it. Your name and then .org? Let's see. Oh, is that how you look? Nice. Then /blog. Okay. I guess I was hiding my screen. I guess it's not important since you're putting that in the YouTube chat, but wait, this doesn't have anything to do with winning out. Oh, okay. Oh, you okay. Well, fine. Oh, wait. Okay. I just realized what at least the LA stands for. Okay. Well, we've been given 2 winning odds for a book. Okay. Let me keep on skimming through this GPT thing. I think I'm nearly done, and then we'll take a look at your linear algebra book chapter. Benedict Rose? I don't know who that is. Mathematician. Passed away in 2025. Number theory. Oh yeah, I don't know about any of this stuff. Harvard professor, department chair for a while. Damn. Sounds like a big deal. I think I saw that on his Wikipedia page. Yeah, representation theories in there. Number theory is primarily though. Okay. Um. Okay, so this is an interesting bit here. So, had the result been produced by a human mathematician, it would definitely have been publishable. So, I think it would be wrong to describe it as AI slop. On the other hand, it seems pointless even to think about publishing it in a journal since it can be made freely available and nobody needs credit for it. So Isaac deserves plenty of credit for creating the framework for which ChatGPT could build. Anderson Archive has a policy against accepting AI written content, which makes good sense to me. Maybe there should be a different repository where AI produced results can live. But various decisions would be made about how it was organized. I myself think that one would probably want to have some kind of moderation process so that results would be included only if a human mathematician was prepared to certify that they were correct, or better still, that they had been formalized by a proof assistant. Perhaps also that they answered a question that had been asked in a human written paper. On the other hand, I wouldn't want a moderation process that created vast amounts of work. For example, was done by AI. Yeah, okay. That's a suggestion, I guess. So these questions are answered. This result is available from the link above. Perhaps now that LLMs are so good at literature search, we have to make it findable. Anyone who wants to know about Nathanson's problem has been solved. But I'm using people refer to him as Dick instead of Benedict. Oh, it does pair interestingly, yes. Abstract algebra learned from those notes. Oh, those lectures. Okay. God, this is too long. That's what she said. Just a few prompts, ChatGPT is able to improve the upper bound from exponential to polynomial. Well, it's first improving the bound from exponential to exponential. So that was a routine modification of my work. The improvement of polynomial in K is quite impressive. ChatGPT came with an idea which is original, which is an interesting choice of word, and clever. So it'd be very proud to come up with after a week or two of pondering. It took ChatGPT less than an hour to find and improve. Using similar methods to those in my own proof. I don't care about the actual technique. Even though I can motivate in retrospect, ChatGPT's idea to use h-squared dissociated sets to control relations of set order at most h feels quite ingenious. As far as I can tell, this idea is completely original. One month when you were touring colleges and ended up at Harvard in the end, though. That's cool, though. Judge level result that ChatGPT found in under 2 hours to be that of perfectly reasonable chapter in a combinatorics PhD. A chapter in a PhD? How long do these dissertations have to be? be considered an amazing result since it leaned very heavily on Isaac's ideas. Definitely a non-trivial extension of those ideas, and for a PhD student to find that extension, it will be necessary to invest quite a bit of time digesting Isaac's paper. Professor might not be optimal for measuring oneself with various algebraic techniques that he used, and so on. Training beginning PhD students to do research has always been hard. Has just got harder since one obvious way to help somebody get started is to give them a problem that looks as though it might be a relatively gentle one. If films are at the point where they can solve gentle problems, then that is no longer an option. I mean, I say that about a lot of things. The lower bound for contributing to mathematics will now be to prove something that LLMs can't prove, rather than simply prove something that nobody has proved up to that point, that at least somebody finds interesting. Have I met any math celebrities? No. No. I couldn't really name any math celebrities really besides like Terrence Tao or Strogatz. Tim Gowers? That sounds familiar. No, I never mind. He's I don't know who this is. That's cool though. Oh, this is his. Oh, wow. Okay. So I have heard of him apparently. Don meets a math celebrity every morning in the bathroom mirror. These people are nothing to me. They're all ants. Um, Qualify that statement in two ways, though. First, there's at a point beginning PhD students' option of using LLMs. The task potentially easier than proving something that LLMs can't prove is proving something in collaboration with LLMs that LLMs cannot manage on their own. Okay, I mean, this is basically confirmation of what I kind of have expected to always happen with LLMs, that they're just going to get better and better and take a bigger and bigger role in like research, but also everything in life. What is the point of struggling with a difficult mathematics problem? One answer is that it can be very satisfying to solve a problem, even if the answer is already known. I don't think that's sufficient reason to spend several years of your life on this particular activity. Fair enough. Better answer is that by solving hard problems, you get an insight into the problem-solving process itself, at least in your area of expertise, in a way that you simply don't if all you do is read other people's solutions. One consequence of this is that people who have themselves solved difficult problems are likely to be significantly better at using solving problems with the help of AI. Okay. Mathematics is a highly transferable skill, and that applies to research level mathematics as well. By doing research in mathematics, you may not get the same rewards as your equivalents a generation ago. It's a good chance you'll be equipping yourself very well for the world we're about to experience. Fair enough. So it's interesting that like they have this very these very concrete examples of ChatGPT contributing something original and clever. Hey, okay, this is a blog post written by apparently a well-known mathematician about just basically like talking about how ChatGPT has gotten really good at doing difficult math, basically. It's not a level like a full-on like math research level, but like basic research it can apparently do. Like there's like it's already done it. Future might not be problem solving in the way we do it today in math. That's true, yeah. I just prompt and interact with the bot while it does all the manipulations, so it's playing with the objects. Maybe. Okay. Leo, I promise I will do, or I will look at your algebra chapter. I just want to quickly do Halo's log equation, because I don't think that's going to take long. And then I'll look at your chapter. Yeah. So yeah, I agree with your first step, or with your suggestion there, Halo. I want to use the identity. No. I will look at it, Leo. Use this identity here. Log base 5a minus log base 5b. Log base 5 x plus 3. Some log base 5 of 4. It actually isn't necessary, to be honest. Actually, no, I wouldn't do this. You can do it, but I don't think it's actually all that helpful. You're stupid and Chungus? Whatever that means. Roll up in the smaller, smaller ball. I would just immediately raise each side to the power of 5 here, which gets rid of the logs entirely. So it's 2 minus x over x plus 3. It's less than 4. And then this is just a standard equation that you can solve, or inequality that you can solve for x. So multiply each side by x plus 3 to get rid of the denominator. So it's 2 minus x is less than 4x plus 3. Distribute this. 4x plus 12. I'm going to add x to each side. And then subtract 12 from each side. So minus 10 is less than 5x. Divide by 5, and then we'll be done. Minus 2 is less than x. If you do the other way of doing it, you're going to end up with the exact same thing as this equation, and I'll show you why. So if I do use that identity, hey Socknow, how are you doing? Any updates? Unless you prefer not to talk about it, of course. So the next thing you would do after this, you still want to raise each side to the power of 5. Like there's no way around doing that step. I don't think. And so what you would do, you have 5 to the log base 5, 2 minus x. Okay. Moving to Rhode Island, you're flying out on July 4th. Okay, well, good luck. I hope that you enjoy it there. Just don't dislike it. Yeah, I would say, like, this line down here, oops, this line right here is the same thing as raising each side to the power of e. So like, or I know that's what you did. Uh, so I'm basically just I'm doing this bottom line down here. Uh, so I could even write ln as, or like, I could write x squared minus 3 as x plus root 3 times x minus root 3 greater than 0. And I could do a log identity on that. It's just not going to be very helpful. And so it's better to just directly raise each side in this problem to the power of e, in the other problem to the power of 5. So it's not wrong, it's not helpful. It's less than 2 and more than minus 2. My criticism because of hunting, fishing issues. Because I have to do another general hunting class because I want to my government classwork on hunting and game. Oh, that's annoying. That doesn't transfer. Didn't count it because it's less than 2 and more than -2. Uh, hey Tyler. Yeah, that does sound annoying. Yeah, I mean, the process you have there is right. Like, yeah, that's good. You should like the only bound that really matters here is x greater than +2. Like you take like the strictest one. Well, no. It could be less than -2. Uh, I just realized, so x squared is more than 4. It actually, you could have x is more than 2, but you could also have x is less than -2. These are both valid things. You tried turning it on and off again? I should try that, Tyler. So actually, if we went to plot this, there's 2 places where it's more than 0. More than 2 and less than 2. And we do need to get both. Sorry, Handle, I'm not sure of a good discrete math channel. That's on the graph you did? Oh no. So yeah, there's a weird thing with inequalities when squares are involved. You have to worry about negatives. But yeah, I do want to get to Leo's blog post here. Uh or freaking linear algebra chapter. Um yeah, I like what you're doing is good. You just need to make sure to like with this inequality, you do need to split out into 2 separate cases, unfortunately. Um One for positive and one for negative. And yeah, for this one up here, it's basically the same kind of technique. I think this one that you posted is probably a little bit you're not going to have the cases in the same way. The only thing you need to worry about is you can't. Oh wait, ha! There is one case we can't allow x equals -3 because of the x plus 3 in the denominator. We have to require x is not equal to -3. So the answer should be -2 is less than x. Oh wait, never mind. That's fine. Yeah, okay, that's fine. No, never mind. Proceed. This requirement doesn't actually end up mattering. Blog post should show the draft of the introduction to a linear algebra textbook chapter, aka peak. Okay. No worries. And feel free to post more, or we can come back to this question too if you still don't understand something. I've just been making Leo wait for long enough, so I want to look through this for a little bit. Doing some more mathematics work on democracy. Still shocked. That's fair. Okay, here's my first draft for the introduction to the first chapter of the linear algebra book. It's a chapter introducing sets and categories. Categories, okay. Try to take a different direction for it. I'm generally curious what people think. There's also a button on top which changes things into reading focus mode. All links are removed, and get out. You must wait for 5 seconds after clicking it again. Okay. Classic Remember Sets, a chapter that infects the early chapters of many mathematics textbooks, often dry and unmotivated, usually serves to make the textbook self-contained more than anything. I find myself fully skipping it more often than not. Yeah, it's usually skip and just come back to it if you need it. With all the material in this chapter, that would make sense to do so. Oftentimes there would be little pieces of set theory I didn't know were necessary for later chapters. Equivalence relations come to mind. Miss these by skipping the entire chapter outright. Are you simply doomed to read another dry set theory chapter in which you know 85% of the material to get 15% novel material sprinkled throughout it? See what I can do about the dryness. Quickly go through the general thing I'd expect most of you to have seen before. I'll also try to test some unique and perhaps more involved examples of sets. Less typically, I'll be casting things in the language of categories throughout the chapter to give a new perspective on set theory concepts. Have you seen the intersection of sets defined via a fibered product in the category of sets? I sure as hell have not. How about motivations? Why do we care about sets and categories in the first place? I sure don't. Let me address this question now. If you give me a few pages, I can explain what role sets and categories play, not just in linear algebra, but in mathematics as a whole. Also correct if you comment misconceptions about the role along the way. Set theory is both the savior and unifier of mathematics around the turn of the 20th century. We've been doing mathematics for thousands of years at that point with great success. We did not have common grounding for the math we did. Eventually issues from this arose, while Aristotelian logic and Euclid's elements hold up well. Newton and Leibniz calculus with infinitesimals posed real problems, in the Italian school of algebraic geometry even proved false results. All this culminated in a need for a steady foundation of mathematics. Right, Cantor and Dedekind. Mainstream math, we conduct in first order theory of sets with CFC axioms. Every object is a set. All arguments about them use for all, there exists, and things like that. Relation A and B. Not the relation A and B. Even this is not really what we do. We write math in English, implicit statement for full proofs that has enough detail that in theory, where mathematician can translate it to first order statements in CFC without having to come up with a new idea. We get some water, because I'm speaking a lot. Every object in math is a set. We have a concept. The Grothendieck analog in the Italian school? I don't know. Maybe a vector space, a ring, rational real numbers to work with. We first need to prove it exists. How do we do so? Build it out of sets. Trying to serve as a material of modern math, because every object made out of sets is sometimes to give you the wrong impression about the concepts being built out of them. So the standard structure construction of the natural numbers, we take 0 to be the empty set, 1 will be a set containing 0, 2 is a set containing 0, 1. Writing out in a verbose way. Okay. Actually didn't know this. Giving people a misperception about what these numbers are. They're sets of sets all the way down, box to box, or the box corresponding to n. Contains precisely boxes n-1, n-2, and so on. Alright, to think about the naturals. If there's a construction of natural numbers out of sets, you could also construct them as follows. What's the difference? Oh wait, I didn't notice. Oh, okay, I actually messed up the nesting in my head. I see what's actually happening in this first definition now. In my head, I just immediately filled in the blank with this. So I didn't look carefully at this one. This construction may be less convenient than the previous one. We can't use the subset relation for less than or equal to, which also extends the common construction of all ordinal numbers well. Yeah, but you're making a point that these aren't the same. Well, they both work, but like they're slightly different. The algebraic geometry professor, if he studied Italian school first, and he said, "Hell no." Hey Obi, what's up? And hey Ayush. Uh, is 2 not a subset of 3 in this construction? Your OBS decided to crap out? What is it doing? It is not a subset of 3? It is the unique element of 3. What? That looks like a subset to me. ISI question paper? No, Ayush. Issue with Wayland slash Sloan combination. A game slash OBS that is running. Good luck. Oh. My OBS has been super weird for a long time. I think one of my scenes is messing with it. And doesn't always, like, close properly. Hope you can get it fixed. 2 would be a subset, and 2 is an element. Well, subsets are elements of another set. I don't get how this is not a subset. Because they refuse to update it in forever because they know. Oh. Elements are not necessarily subsets? What? You felt this year's subjective part was easier, that boosted your confidence? Oh, okay, good. Is that not true, Leo? Like, if A is an element of B, the singleton set containing only A is a subset of B. A type error? I don't get what... I can just move on, but I really don't understand this. Or like, I don't understand, like, oh, it's not a subset. It's probably isn't important to, like, your actual point here, so we could just move on. I can write x plus 1 squared plus y minus 3 squared equals 10 in polar form. So you have the real numbers R, intervals are things, subsets of R, a single number. It's not? Why is a single number not a subset of R? Okay. What's the difference between A sub n in F and A sub n in F? I guess one is a set, the other isn't. Shared processing application Yahoo. Oh, that 1024%. That something's a little off there. Converting that to polar form. That's kind of funny. How do you YouTube app using 50% CPU? Oh my god. I know, I'm getting stuck in the preface. And now I'm even going back to ignoring him for a second to think about this question. Expressions that are singleton sets of size 1, so they only have two subsets, empty set and itself. Okay, Anis, I just have to take you at your word, because that just seems weird. You might have to go soon? Okay, I'm sorry if I take too long on this. 1, 2, 3. Okay, so PV cleanse, I can tell you, like, there is like a simple thing that we could do. It just feels a little bit wrong just to leave it like that, but this equation is the equation of a circle. It's centered at -1 for the x and +3 for the y, and the radius is square root 10, so 3 point something. Just like to show you like what this equation means. Okay, so that's helpful to know. So for polar form, I guess for this one, there's two important equations. At least for this, well, there's a few important equations. X equals r cosine theta, y equals r sine theta. And it may be helpful later on, x squared plus y squared is equal to r squared. And so the thing I was gonna do is just plug these two things in directly and call it a day, but we do have to isolate r, so that's gonna take some extra work. I think a polar form for a circle not centered at 0 is probably kind of annoying. I don't expect this to be very clean. Just thinking what I can do to save work first. Okay, so I'm going to multiply this out before I do anything else. So x squared plus 2x plus 1 plus y squared minus 6y plus 9. Oh. I think we're still gonna have work if we do that, usually. I don't think there's a way around doing this multiplication out. Maybe I'm wrong. It's gonna be radius as a function of theta, Dessen. I think that's what they want. Where's this going to go? I'm a little worried that this, I don't know if I'm going to do this right, but 1 plus 9 is 10, and there's a 10 over here. So I can subtract 10 from each side. We'll have x squared plus 2x plus y squared minus 6y is equal to 0. And then x squared plus y squared is r squared. Nobody uses polar form. And then the x is r cosine theta, the y is r sine theta. Polar form was great. And I guess we divide R out from each side. It kind of just gets thrown away. And I think that's okay, because we don't care about R equals 0. So we get R plus 2 cosine theta minus 6 sine theta equals 0. And then just subtract these two things to the other side. So R is equal to 6 sine theta minus 2 cosine theta. That's not as bad as I thought it'd be. Yeah, I just figure I assume we're still gonna have some multiplying out to do or something. And let me graph this in Desmos. 6 sine theta minus 2 cosine theta. Oh, look at that. Okay. You don't need to expand? Okay, well, this way works too, and it's to me it's a little more like natural. Yeah, so in general, BV cleanse, like, it's usually kind of dangerous to just divide out an R like that. Because like you need to worry about the like whether it could equal 0. I guess the more proper thing would have been to factor an R out. And then you get two different cases. Either R equals 0 or this other bit here equals 0. Oops. No R there and no R there. And we would just throw this case out because we don't care about R equaling 0. And then this equation here is the same as that. So I guess unless it's a little more proper. That's pretty common. Like when I first learned polar form, they made us do that kind of commonly, Dessen. Those are identically 0? Yeah, that's fair, Leo. You know the equation for ellipse or circle. How about a square, a rectangle, triangle? Oh god, Papadoria. I mean, it'd have to be piecewise. And you have to deal with the vertical lines. I guess for triangles you could do an absolute value. That's still basically piecewise though. Purpose of category theory. True. Let's go back to this. Dreg final review. Ooh, good luck. Shameless Leo. Okay, we're just gonna blow past that whole subset thing because I still have a hard time believing that. But who cares? Starting here. Where does category theory fit in all this business? In some ways, category theory resolves a problem that arises from constructions being arbitrary. We're working with various different objects. It is a hassle if we have all of these different constructions of them. When I refer to the natural numbers, which natural numbers do I mean? It really shouldn't matter which natural numbers I mean. For whatever incarnation natural numbers, I should get the same results. How do we specify that? Damn, Leo, for 3 minutes? That sounds mean. Let's try to do the same exercise for definitions of a product of two sets. The same definition of product of two sets is as follows. Right. That Cartesian product. What is A comma B? Every object is a set, so this must be a set of some sort. However, if A is not equal to B, then AB is not the same as BA, so it certainly is a set AB. In general, we construct AB as AAB. Really? So we can find the first element of the ordered pair by looking for the... Oh, okay, sure. We could also have the construction as A, B, B. First construction proposed was the ugly. Oh, that is ugly. Quite a few options. Category theory lets us cut through its arbitrariness. How would category theory tackle the definition of a product of sets? Beautiful picture. I assume you're talking about the category thing below here. Piecewise is bad. Let's say for the sake of humanity, the absolute values are not piecewise. Can we go a triangle as a rectangle is just scaled square in 1D. What does that mean? Triangle as a rectangle is just a scaled square in 1D? What is a one-dimensional triangle or a one-dimensional square? Or it's scaled in one dimension. Okay, no, I see what you mean now. Like you're only scaling one piece of it. But even then, like absolute values are too rigid. Like if you want, they can only make a 45-degree angle, right? What if you don't want a 45-degree angle? Clearly, minus absolute value of x on the diagram in the blog post. It is. Hint taken. It is hard to keep me on track. On one task. How comfortable are you with category theory? What's my take on it? I know nothing about category theory, so I'm not comfortable at all with it. My take on it is that I probably wouldn't like it. I guess we're about to learn maybe the first thing about category theory right now, though. Okay, definition. The product of two sets AB is a set S along with two maps. Pi sub A maps S to A. Pi sub B maps S to B. Such that for any other set T with maps F T to A, G T to B, there is a unique map. Oh god. T LFG? L sub FG, such that pi sub A composed with LFG equals F. What the hell does this mean? The first rule of category theory is to have fun. I'm already breaking the first rule. Apparently I'm having fun. I've just been informed I'm having fun. I'm having so much fun, guys. Okay, the product of two sets is a set S along with two maps. Something that maps S to A and S to B, such that for any other set T with maps T to A and T to B, there is a unique map T. I don't know what the LFG thing is, but I guess it doesn't matter. Such that pi sub A of L equals F. So this is saying that these F and G are really not so different from pi and B. They're just a transform away from each other. LFG, let's fucking go. That's true. Go to the second picture. That's the definition. Leo took too much inspiration on Keel for the yapping. Raven, my brain is hurting because this is the first thing I ever tried to learn about category theory. The rest of the chapters dissecting the argument. Okay, good. Because I'm going to need that. What a terrible jumble of words. If this is what offered by category theory, do we really want it? I don't so far. The answer to this may, and of some and jubilance for others, is yes. And if you give me a moment, maybe I can untangle the mess a little bit. Let's start with the product S pi A pi B. Yeah, Raven. I mean, when you learn about cohomology, you generally cannot probably understand it to be any sort of fun. I probably wouldn't like that either. Seems rather different from the set theory definition of product. Instead of a single set A cross B, or A times B, we have a set S in two functions. These two definitions are perfectly compatible. In fact, we can use the construction A times B to understand pi A and pi B better. I also hate using pi for something that's not 3.141592. If we let S equals A times B, we can define pi A and pi B as follows. Pi A of AB is A, pi B of AB is B. Okay. Right, because pi takes S as an input. Sure. The maps pi A, pi B exactly encode the relationship between the sets of pairs S equals A times B and A and B. We can even define A, B, and S as the unique element mapping A and A under pi A into B and B under pi B. Now then, what about all that other business with another set T with maps A to A and B? Let's see. We got a more complicated one. That's because cohomology is hidden from the long exact sequence you get by approximately at least 2 times with short sequences. Okay. It's the type of thing I make AI teach me like I'm dumb. I would need that, Raven. You know, with the way category theory terms go, cohomology implies the existence of something called homology, as if. Ugh, it's okay, Raven. I don't really know either. Okay, what's up with this diagram? T, let's fucking go S. I use projections a lot. This is standard notation. Yeah, I've seen pi used like in non-category things. I've seen like in probability I've seen pi get used for non-pi things or like non 3.14 things. I know they do it in economics a lot too. Okay, so the dotted line is a mapping from T to S. Okay, for any set T, it maps FG to A and B. Respectively, we get a unique map. Is this an L, by the way? I'm just assuming it's an L. It might be an iota or something weird. Making the all compositions in this diagram agree. It is iota? Okay. I don't think of products has a definition in words. I think of it only in diagrams like the second one. Okay. For induced. Salsa verde, welcome in. I was just basically doing that same thing in real life, so if you're feeling that way, you're not alone. I am not a category theory person. Pi sub A of iota equals F. Or inclusion. No, it's been the same. So I made that redeem like at least a year ago. It has not changed once since no one has ever gotten it. It only changes once someone guesses it right. Pi sub A of iota. Okay, oh, this is like, okay. And in this case, iota comes first and then pi. I always get confused with the function composition notation because I feel like some people do the opposite, where they will put iota of pi sub A. And that's why I was confused with the ordering. But okay, yeah, this makes sense. Maybe. Yes. Because there's two different paths from T to A. One is along F, one is along iota, and then pi. Thanks for the follow, Salsa. I know that diagram looks like a funny rotated Pac-Man. You know, that's about as intelligent as I feel like I can say too about this thing. Welcome in though. If you have anything that you'd like to talk about, please do let me know. This is like a draft introduction chapter of a textbook that Leo lectures in chat is writing, so we're just going through it. This is not anything that I've ever learned before in my life, though. Think like this. A equals 2, B equals 3, S equals 6, T equals 6x equals 6, 12, 18, 24. And 2 times 3 equals 6. Sort of? That's not... I would need to think about that more. Is the iota map expressing how you get from two functions to A and B respectively to a map to the product S? Leo is saying that you're getting it, so I would assume yes. Yeah, I'll scroll back up and show the original thing. We're talking. This is all about this definition here, which is a category theory way of defining the product of two sets. And we're trying to unpack the definition, understand it. So I'm going to scroll back down. The second was the original model for Pac-Man. What category theory object would this category theory Pac-Man be eating? Or what ghost would it be running away from too? It's like the music just stopped. Let's do this song. I haven't listened to this song in a minute. He's eating my brain. Yeah, same. I can do this. I don't know if I can. If this property holds for any t, let's start with the simplest t we can think of. The 1 point set. T equals star equals point. In this case, giving a map from F point to A, so I'm picking element A and A. The element F maps point 2. Similarly, G maps point to B encodes elements of B. What does it mean to have a unique map iota FG such that the above compositions hold? Well, maps star to S encode elements S and S. Unrolling the definitions, we find this translates into the statement: for any two elements A and A, B and B, there's a unique element S and S such that pi sub A of S is equal to A and pi sub B of S is equal to B. My engineering friend can learn what a Lie algebra is. You can do this. Ugh. You have to watch porn 16 hours of machine turn enough coffee beans to try every combination. You know, I could probably make that redeem a little bit cheaper too. It could come down to like 300. Warren points is powerful YouTube frog. I blame YouTube. They only implement super weird features that aren't actually ever helpful. Okay, you know what? Oh wait, did I just find it? Oh, okay. I can't easily update. Or I can't update it right now, but at some point, if I remember, I'll bring the price down a bit. I was thinking about doing that anyway. In this case, giving map F star to A, simply picking element A and A. Okay, I think I maybe am on board so far. We call that unique element AB. Starting to see how this characterizes what we want out of a set product. The set of pairs of elements. We'll see how this is encoded using the mapping pi A, pi B. If it means we haven't gone to yet, is it well-defined? Let's call it well-defined even means. Often in mathematics, we define something in terms of properties that it holds. We define root 2 as a positive real number r such that r squared equals 2. This works fine. If you try to define root -1, you'd have a terrible problem. Right. It's a complex number. That's the second option. Problem is just swept under the rug. There's two possibilities, right? Mr. Textbook Man, aka Leo, can you get from t equals point case to general t by looking at maps point to t for arbitrary other t? Mr. Textbook Man. House also already 3 out of 3. Oh, hey, okay. You're rocking it, Salsa Verde. You should be teaching me here. I'll drop the link to this in chat too. I just realized that I didn't do that. It's better to have a hen tomorrow than an egg today. Oh, that's a good fortune. It's technically not well defined. Yeah, because like polar form is the one true definition. Examples, we see the two key ingredients for checking that something is well defined. Must exist and be unique. Yeah, it's a chicken. It is a banger. Usually they're pretty bad, but that one's a good one. Must exist and be unique. Transitioning back to the categorical set product. Does it follow these rules? Eggs are great. I like eggs too. For existence, we can use set construction for A times B to furnish an example of a categorical product. The rule set theory plays for working mathematician. I reminds me of like how people it's talking like the 2000s on the internet. There's a typo. This entire book is ruined. It's to show existence. He's a millennial. Come on, everyone knows about ICANN has cheeseburger. Category theory steps in for uniqueness. However, the categorical set product is not unique, at least not in the usual sense, though it is unique in a more useful way. Press F5 for the typo. Claim. The categorical set product is unique up to unique bijection. That is, for any two set products, there is a unique bijection. Yeah, this is what the T thing was all about. Like, there may be multiple possible mappings, but they're all essentially the same thing, is how I'm interpreting this. I'm cooking? Okay. It's also Verde on notice. As S is a categorical product, we can induce a map iota S to S prime such that the compositions above hold. Don't lower the lotto difficulty? Okay. I'll leave it there if you want. You're the person who's played it the most anyway. We can induce a map iota prime S prime to S such that the unique map. Sure. We know these two uniquely defined maps, the composition properties we want. What remains is to show us they are mutually inverse. Okay. It's equal to identity. You can do this with the following slick trick. Stacking the diagrams on top of each other. Yeah, that's the technique, Raven. Like, you gotta note when you or someone else tries to play it. So the tautological diagram. Oh, yeah, okay, sure. All the common properties, you'll notice Pac-Man cannibalism maneuver? True! Why does the bigger Pac-Man not simply eat the smaller Pac-Man? Well, he did, and this is the result. I much prefer the Pac-Man interpretation for category theory so far. If you follow the composition properties, you'll notice that pi a of iota, so iota prime, pi a, is equal to iota, I'm getting lost, iota prime, wait, oh, that's just associativity, okay. Pack on pack violence. Know about Matthew having a gambling addiction? True. Any path you go from one to the other will have the same result? Okay. Yeah. It's like your 2 times 3 example, but just fancy. I still have to think about that, because I sort of see how it connects, but not entirely yet. Oh, okay. So you're comparing this equation with this equation. Okay. Symmetric argument shows that, yeah. Ooh, slapping the QED on there. It's also already helping out with Raven's gambling addiction. A mapping, it's just a function. We're talking about mapping sets to sets, and so it's just a function. Practice safe sets, kids. It's good advice. I'm pretty sure. Unless you mean to salsa. So at this point, we have now fully characterized the categorical set product. We have showed it as unique, at least in a categorical way, instead of exactly one set, which we call the set product. Well, for a whole family of sets to be the set product. However, each such set, that's like a tongue twister, has maps attached to it describing how it is a set product. And for any 2 such set products, there is a unique bijection identifying them. It is indeed just a function. Okay. Your finite safe sets or infinite safe sets? Unlimited sets. Ugh. Good with either on safe and well-founded. Yeah. Okay, hey, we're almost at the end. I see footnotes. Refer to definitions kind colloquially as universal properties. Universal properties will characterize many categorical notions such as products, coproducts, limits, colimits, and even many functors and adjunctions. They all come up with a similar flavor. We'll have some properties of an object expressed with maps. You'll get an induced unique map to or from the universal object to or from other test objects. For set product, we said the product was unique up to unique bijection. In general, we'll say things are unique up to unique isomorphism. We'll define what isomorphism means later in the chapter. For sets, it suffices to say isomorphism is the same as bijection. Category theory plays this clarifying role well. It shifts one's perspective from that of defining unique objects to defining objects which are unique up to a kind of equivalence. This is not the only role category theory will play. It also shifts one's perspective. Prospectus. Another typo. It's double ruined. From the object-oriented to the functional, and it will be a key piece of language useful for higher mathematics. Textbook guide double owned. Product of groups can be reformulated as shown on this blog. What is the product of two groups? I might have learned about that, but I don't remember. How does the operation work? Do they have to have the same operation? Teaching category theory, unfortunately, is notoriously difficult. It often attracts many young students. It has the allure of being modern universal while also requiring nearly no prerequisites. Oh, that's interesting. This often yields a class of zealots with little understanding of what category theory is for. They have learned a lot of language without learning about any of the subjects the language talks about. However, the typical mathematical education in category theory might not be much better. Usually one will pick up categorical notions by osmosis. They'll be sprinkled like breadcrumbs into different higher level classes. How many crumbs you get is dependent upon the taste of your instructor. In this book, I hope to give a unified account of all the basic notions of category theory that are useful to a working mathematician, giving some context for all of them. Within linear algebra, you can find examples of all categorical notions you may care about: limits, colimits, functors, adjunctions. Even some discussion of abelian categories will all pop up throughout this text, and it will be clarifying to anyone who dares to read on. Okay, so he was getting interested? I don't know if I would say interested. Categorical product of two groups is actually kind of gross. It's called the free product. Oh, okay. Principle of continuity roughly states property P. Sure, I is not well defined. Huh. Okay. Hey Naman. Yeah, shout out Salsa. How's the math? Uh, I've been forced to learn about category theory, color cone. I was tricked into it. I was promised linear algebra and I was given category theory. So I didn't go to eat today. I found out there's a... Yes, it's one of my favorite things in math, Naman, called the Volterra equations. They're super cool. So okay, so it sounds like the overall point of this is that you're going to use category theory to not worry about specifics of how you define things in linear algebra, or just like to get away from it sounds like you're trying to just not get into the weeds of making very specific definitions, and that's your argument that you're making here. One way to do it / see it. Okay. Meth is good after safe sets. The theory for showing existence, category theory for uniqueness in the right way. Okay. Well, I mean, I guess well done, Leo. You actually made me sort of understand something from category theory, which, you know, I would have assumed is impossible. It's crazy you read that I actually can't read, only write. You can only write, but not read. That would be a hell of a handicap. Not about the size of the set, but about how you use it. Exactly, Salsa Verde. Think of any construction, it has a universal property. What is the universal property of the real numbers? Okay, they're not imaginary. That's true. The universal property of real numbers is unique ordered field that completes Q. Well, minimal. Okay. Category theory hates equality nowadays, just like rich people. Yeah, I always thought of category theory as the bougie rich person math, so that checks out. It's the minimal among those that among you ordered fields that complete Q. Okay. You've been getting paid after posting this? Says the boy from Cali. That's true, Jed. Okay, I might go back to looking at my cancer modeling papers, but you know, claps for Leo actually creating something, or at least the start of something. You define naturals via a category of stuff, and the non-minimal ones are non-standard naturals. Gotta go play. Oh, that is very important business. Well, enjoy, Leo. Unique up to isomorphism? Yeah. Imagine math oncology with category theory. I'd rather not. Go back to eating my organic vegan snack with my bottled spring water. Mm-hmm. I think that, like, oh my god. Sparkling water is what's all the rage now. No worries, Leo. Thank you for sharing. Okay. I probably shouldn't stream for too much longer, but let's get caught up on where I was with this paper. So this is about resistance to chemotherapy, patient variability, and cellular heterogeneity. Sparkling water is all the rage now. You're ahead of the curve. Drinking that for like 5 years. I mean, I don't know if it's the rage now. I've just been thinking like sparkling water is kind of maybe over the last like 5 years or so. I feel like it's gotten big. Jed is trending. Yeah, you're very hip. You know, you probably set that trend, Jed. Everyone else was just copying you. Um, what is this with Luria Delbruck again? Now that I've read the definition, do you think having babies is a product? There's a unique blood relation map from the grandpa to your son. Probably? I don't know. Oh my god, I'm already yawning. I randomly woke up at 6:30 in the morning today and was wide awake. And that never happens to me. It's normally a struggle to like be awake before 8 for me. And maybe it's a product for some, but a dividing factor for others. That's true, Jed. Oh, right. This is a really cool application of math. Um, you can use probability to figure out how mutations arise in bacteria, and counterintuitively, um, these mutations tend to arise when there is not selective pressure rather than when there is selective pressure. Or at least, like, you don't necessarily like, need the pressure, it just kind of happens. And you can do that by basically assume like there's two alternatives here. You can assume that either is true and then go and do math to figure out what the distributions are for the expected number of mutations. There's so much time. And they're different enough that you can compare it to data and get an idea of which one must be the right one. Does it say the actual distribution? Yeah, here it is. This box text here is probably worth reading, so let's do that. Okay, skimming. In our example, an individual patient has a specific number of cells and mutation that are present before treatment and harbor a mutation that confers resistance. This number is a sample, one number drawn from Luria-Delbruck distribution set of probabilities. PID. And that represents the fraction of occurrences or patients whose tumors harbor N mutation cells with sigma PID of NMUT equal 1. They're going to use some of those websites where you send your saliva and pay $200 to figure out your ancestry. No, but one of the papers I was talking about earlier with phylogeny trees, maybe it could be something like that. We know simple computer algorithm, draw a single random number, call it X from uniform distribution between 0 and 1, determine NMUT by the condition. Sure. Repeat this procedure for some number of times by drawing successive samples. Generate proof of a pool of synthetic data with each data point representing a single patient. The wiki? Yeah, oh, yeah, no. There are trees here, but I don't think this would be helpful for ancestry. In figure 2, we have plotted as circles the results of creating a patient pool of size 100. Each circle is the number of individuals with a specific NMUT. Note the y-axis ranges from 0 to 15. The circle on the y-axis itself indicates that there are 8 occurrences or 8 patients whose tumors do not have any cells with mutations. Okay, 8 patients whose tumors do not have any cells with mutations. 2 highest circles represent 11 occurrences or patients whose tumors harbor 1 or 2 mutant cells. Plot as 2 and 3 on the y-axis. This is a little more explanation than I think I needed for this figure. Okay, that's fine. Let's keep looking through for figures and equations. Ooh, this is pretty. It kind of hurts actually to look at. I don't know why these colors are like messing with my eyes. What are these axes? Patients treated with vemurafenib, percent change from baseline in longest diameter of target lesion. So a small number of patients had an increase in size of lesion. I assume that the treatment just completely failed then. But a fair amount of them had a 100% reduction. Interestingly, the stage doesn't seem to matter. Well, stage 2 is pretty heavily on the right, but the other two stages are kind of distributed throughout. Typical patient response data depicted as a waterfall plot. Shown here is a percent change from baseline for best result or maximal response. Okay. Synthetic waterfall plots, patient maximum response, fractional change in tumor radius. Oh, okay, I guess mu is probably the mutation rate. And so the red line has a higher mutation rate. And so it makes sense that I think the higher mutation rate has a worse response overall. So I think you want to be by -1. Maximum response, fractional change in tumor radius. I don't know what's going on here. This is just a filled in version from above of the plot above, I guess? Hmm. I don't know. I am running out of thoughts to have about things right now. I think trying to learn about category theory has made me too tired to think about this right now. Hmm. Yeah, I think we might just call it here. So yeah, and who's here on YouTube, thanks for being here. I may be back on Thursday. We'll see. See you, YouTube.